Picture this. It's 2016, and you're a researcher at DeepMind, staring at your monitor at 3 a.m., watching your AI lose at Go for the millionth time. Your coffee's gone cold, your eyes are burning, and you're starting to wonder if maybe your parents were right about that law degree. Then something clicks, not in your code, but in your brain. You remember something from a dusty mathematics textbook from the 1700s. Something about a guy named Thomas Bayes, who died before anyone cared about his work. And that's when everything changes. Before we dive into how a dead priest's math homework literally rewrote the future of artificial intelligence, smash that like button if you've ever wondered why your phone seems to know what you're thinking. Drop a comment below telling me the creepiest thing AI has predicted about you. Trust me, after tonight's story, those predictions are going to make a lot more sense. Now grab something stronger than coffee, kill the lights except for your screen, and let's talk about the day ancient math met modern machines and created something that would beat the world's best Go player and change everything we thought we knew about intelligence. You need to understand something first. In 2016, AI was having what we call a crisis of confidence. Sure, we had Siri butchering our names and autocorrect creating embarrassing text disasters, but real AI, the kind that could think and reason, that was stuck. Imagine trying to teach a toddler calculus by showing them a million calculus problems. That's essentially what we were doing with neural networks. We were force-feeding them data like a competitive eater at a hot dog contest, hoping something would stick. The problem wasn't the data or even the processing power. We had plenty of both. The problem was that our AI was like that friend who memorizes everything for the test but can't apply it to real life. They could recognize a cat after seeing 10 million cat photos, but show them a cat wearing a hat. System error. Brain explosion. Does not compute. Here's where you come in. You're sitting in that DeepMind office, and you're part of a team trying to crack Go, an ancient Chinese board game that makes chess look like tic-tac-toe. Go has more possible game positions than there are atoms in the observable universe. Let that sink in for a second. More positions than atoms in the entire universe. Your traditional brute force approach, the one that worked for chess, is about as useful as a chocolate teapot. You can't just calculate every possible move because the heat death of the universe would happen first. Literally. So what do? You dig deeper. You look at how humans play Go. Humans don't calculate every possibility. They use intuition, pattern recognition, something that feels almost magical. They look at the board and just know where to place the next stone. But how do you teach intuition to a machine? How do you program gut feelings? That's when someone on your team, probably sleep deprived and possibly hallucinating from too much Red Bull, suggests something insane. What if we don't teach the AI to play Go? What if we teach it to teach itself? This is where Thomas Bayes enters the chat from beyond the grave. Bayes was a Presbyterian minister in the 1700s who probably never imagined his math would one day help machines think. His big idea was deceptively simple. Instead of looking for absolute truth, look for probability based on evidence. Update your beliefs as new information comes in. It's like how you decide if it's going to rain. You check the weather app, sure, but you also look at the clouds, feel the humidity, notice if your grandma's knee is acting up. You're constantly updating your rain probability based on new evidence. Bayes figured out the math for this back when electricity was still considered witchcraft. Now you're probably thinking, okay, cool, dead math priest, but what does this have to do with AI beating humans at board games? Everything. See, the revolution wasn't just about using Bayesian probability, it was about combining it with something called Monte Carlo tree search. And no, that's not a fancy cocktail. It's a way of exploring possibilities by random sampling. Imagine you're lost in a massive maze. Instead of trying to map every single path, you send out a bunch of drunk robots who wander randomly. Most will hit dead ends, but some will stumble toward the exit. You learn from all of them, even the failures. Especially the failures. Your team at DeepMind realizes something profound. What if instead of programming every Go strategy, you create an AI that uses Bayesian inference to update its beliefs about good moves, combined with Monte Carlo sampling to explore possibilities? What if you create an AI that learns like a human but thinks like a computer? The hybrid approach sounds good on paper, but implementing it is like trying to teach a fish to climb a tree while the tree is on fire and the fish is questioning its life choices. You need the AI to balance exploration with exploitation. Too much exploration, and it's just making random moves, like your uncle playing chess after Thanksgiving dinner. Too much exploitation, and it gets stuck in patterns, like that person who orders the same thing at every restaurant. The breakthrough comes when someone suggests something even crazier. What if the AI plays against itself? Millions of games, billions of moves, each game teaching it something new, updating its probability distributions, refining its intuition. It's like having a time loop where you get to practice the same day over and over until you're perfect at it, except the AI can do this millions of times per second. While you're sleeping, while you're eating breakfast, while you're stuck in traffic wondering why you didn't become a lawyer, the AI is playing Go against itself, getting better with each game. But here's the kicker. The ancient algorithm, Bayes' theorem, isn't just calculating probabilities. It's doing something far more profound. It's learning to deal with uncertainty, the way humans do. It's developing what we might call intuition, that gut feeling about what move feels right even when you can't explain why. Let me paint you a picture of what's happening inside this AI's silicon brain. Every position on the Go board becomes a node in a vast probability tree. The AI doesn't see individual stones anymore. It sees patterns, shapes, potential futures, branching out like a cosmic web. Each possible move creates ripples through probability space, and Bayes' theorem is the mathematics that surfs those ripples. The AI is literally dreaming in statistics, hallucinating futures that haven't happened yet, and choosing the path most likely to lead to victory. You want to know the really freaky part? Comment below if this keeps you up at night, like it does me. The AI starts developing strategies that no human has ever used. It's not copying human masters anymore. It's inventing new ways to play a game that's been around for over 2,500 years. Moves that look insane to human experts, but turn out to be genius. 10 moves later, it's like watching someone solve a Rubik's Cube by first making it worse, then suddenly everything clicks into place. The Go community starts calling these alien moves. Moves that work but shouldn't. Strategies that violate everything they thought they knew about the game. March 2016 arrives like a storm. AlphaGo, your Frankenstein creation powered by 18th century math and 21st century processing, is about to face Lee Sedol, one of the greatest Go players who ever lived. The guy's a legend. He's been playing since he was a kid, has won 18 world titles, and his brain is basically a biological Go computer. The smart money is on Lee. I mean, come on, it's man versus machine, and we all know how those movies end, right? Humanity prevails, roll credits, someone learns a valuable lesson about the power of the human spirit. Except this isn't Hollywood. This is real life, where math doesn't care about your feelings. The first game starts, and you're watching from the DeepMind office. Your palms are sweating, knees weak, arms heavy, but instead of mum's spaghetti, you're sustained by energy drinks, and the existential dread that you might have created something you don't fully understand. Lee Sedol sits across from a computer monitor, representing AlphaGo. The AI doesn't have a face, doesn't trash talk, doesn't even know it's playing against a legend. It just calculates probabilities, updates beliefs, explores possible futures. Move 37 happens. If you know, you know. If you don't, let me tell you, this moment gave everyone watching genuine chills. AlphaGo plays a move so unexpected, so against conventional Go wisdom, that Lee Sedol gets up and leaves the room. He needs a cigarette break to process what just happened. Commentators are baffled. Is it a mistake? Is the AI broken? Then slowly, like watching a spider build its web, the beauty of the move becomes apparent. It's not just good, it's transcendent. It's the kind of move that makes you question everything you thought you knew. The ancient algorithm isn't just winning, it's revealing new truths about a game humans have been playing for millennia. It's like finding out there's been a secret room in your house the whole time, and all you needed was the right key. Bayes gave us that key in the 1700s, we just needed 21st century technology to turn it. You wake up the next morning, and the tech world has lost its collective mind. Headlines scream about the robot apocalypse. Your Twitter feed is a dumpster fire of hot takes, ranging from AI will save us all to we're basically doomed and should start hoarding canned goods. But you know the truth. This isn't about robots taking over. This is about something far more interesting. We've just taught Silicon to deal with uncertainty the way biology does, and that changes absolutely everything. Let's rewind and talk about what Bayesian inference actually means for your daily life, because I promise you're already using it, even if you failed statistics class. Every time you see dark clouds and grab an umbrella, you're doing Bayesian inference. Every time you swipe left on a dating app, because their bio mentions CrossFit one too many times, that's Bayesian probability at work. Your brain is constantly updating beliefs based on new evidence. The revolutionary part wasn't discovering this, it was teaching machines to do it at superhuman speed and scale. Think about what this means. You're training an AI that doesn't just pattern match like a very expensive parrot. It's building an internal model of the world, complete with uncertainty and probability distributions. It's not memorizing that cars stop at red lights. It's understanding that cars usually stop at red lights, but sometimes they don't. And here's the probability distribution of when they might not. And here's how that probability changes if it's raining, or if it's 2 a.m., or if the driver is in a vehicle with racing stripes. The AI is learning context, nuance, the gray areas that make the real world so frustratingly complex. But here's where things get spicy. Drop a comment if this makes you uncomfortable. The same algorithm that conquered Go starts spreading everywhere. Your Netflix recommendations, Bayesian inference, that creepy moment when Instagram shows you ads for something you were just thinking about. Bayesian inference with a side of data harvesting. The spam filter that somehow knows that email from a Nigerian prince isn't legit, even though this one promises it's different. You guessed it, our boy Bayes is working overtime. The ancient algorithm has infected everything, spreading through our digital infrastructure like a beneficial virus. You're now living in a world where every app on your phone is running some variation of this centuries-old math. Your smart home is using Bayesian networks to predict when you'll want the lights on. Your car is using it to predict when that pedestrian might step into the street. Even your doctor is using AI systems, powered by Bayesian inference to diagnose diseases, updating the probability of different conditions based on your symptoms, test results, and medical history. That persistent cough and fatigue. The AI is calculating whether it's just stress or something that needs immediate attention, using the same mathematical principles that helped AlphaGo destroy human champions. Let me blow your mind with something. You know how your phone's predictive text seems to know what you're going to say before you do? That's not magic or mind reading. It's Bayesian inference on steroids. Every time you type, you're feeding data into a probability model that's constantly updating its beliefs about what word comes next based on everything you've ever typed before. It knows you always follow. Hey with there, not there or there, because you're not a grammar monster. It knows you end work emails with regards, but texts with lol or crying emoji. The AI has built a probabilistic model of your language patterns. That's so accurate. It's basically a digital twin of your communication style. This gets darker when you realize the same math is being used to predict more than just your next word. Insurance companies are using Bayesian models to predict your likelihood of filing a claim. Banks are using it to decide if you're worthy of a loan. Employers are using it to screen resumes. The algorithm that revolutionized AI in 2016 is now making decisions about your life, and most people have no idea it's happening. You're being reduced to probability distributions, your entire existence compressed into statistical models that update every time you click, swipe, or buy something online. But wait, there's more. As they say in infomercials, the really wild part is how Bayesian inference handles what we call prior beliefs. In human terms, these are your assumptions, your biases, the things you believe before you see any evidence. The algorithm starts with priors, then updates them as evidence comes in. Sounds reasonable, right? Except those priors can be programmed with biases, intentionally or not. If the prior belief is that people from certain zip codes are more likely to default on loans, the AI will need overwhelming evidence to overcome that prior. It's like trying to convince your conspiracy theorist uncle that the moon landing was real. Technically possible, but you're fighting uphill against some strongly held priors. You're probably wondering how we got from a dead priest's mathematics to AI that can beat humans at their own games and predict your behavior better than you can. The secret sauce was combining Bayesian inference with deep learning neural networks. Imagine Bayes' theorem as the philosophical framework, the way of thinking about uncertainty and probability. Now imagine neural networks as the machinery, the raw computational power. Separately, they're powerful. Together, they're unstoppable. It's like combining chocolate and peanut butter, except instead of a delicious snack, you get artificial intelligence that can learn, reason, and adapt in ways that seem almost alive. The 2016 revolution wasn't just about winning at Go, it was about proving that machines could handle uncertainty and incomplete information the way humans do, but better, faster, more consistently, without getting tired or emotional or distracted by their phone buzzing with notifications. The implications rippled out immediately. Medical diagnosis, financial modeling, climate prediction, drug discovery, all of them suddenly had a new tool that could navigate uncertainty with mathematical precision. Here's something that'll make you question reality. The Bayesian approach to AI revealed something profound about intelligence itself. Intelligence isn't about knowing everything. It's about making good decisions with incomplete information. It's about updating your beliefs when new evidence arrives. It's about navigating uncertainty with grace. Sound familiar? That's literally what you do every day. When you decide whether to trust someone new, when you figure out the best route to work, when you guess what your partner wants for dinner based on subtle cues and past experience. You're a biological Bayesian inference machine, and you didn't even know it. The AlphaGo moment was like the 4-minute mile. Once it happened, suddenly everyone realized it was possible, and the floodgates opened within months. Variations of the algorithm were everywhere. AlphaGo Zero came next, and this one was even scarier. It learned Go from scratch, without any human games to study, just the rules and Bayesian reinforced self-play. In 3 days, it surpassed the original AlphaGo. In 21 days, it reached superhuman level. In 40 days, it became arguably the strongest Go player in the universe, human or machine, all from playing against itself, updating probability distributions, learning from uncertainty. You want to know what keeps AI researchers up at night? Comment below if this thought has crossed your mind. It's not that AI will become conscious and decide humans are obsolete. It's that we've created intelligence that works in ways we don't fully understand. When AlphaGo makes a move, we can trace through the probability calculations, see the Monte Carlo simulations, understand the Bayesian updates. But the emergent strategy, the creativity, the intuition that emerges from complexity in ways we can't fully predict or control. We've summoned something using 300-year-old math that exhibits behaviors we never programmed. The really trippy part is that Bayesian inference might be how your own brain works. Neuroscientists are finding evidence that your brain is essentially running Bayesian calculations all the time. When you catch a ball, your brain is predicting its trajectory using Bayesian inference. When you recognize a friend's face in a crowd, Bayesian pattern matching. When you understand garbled speech in a noisy room, Bayesian signal processing. The ancient algorithm that revolutionized AI might be the same one that's been running in your skull all along. We didn't invent artificial intelligence. We discovered and replicated natural intelligence. By late 2016, the genie was out of the bottle. Every tech company was scrambling to implement Bayesian approaches. Google's search algorithm got a Bayesian upgrade. Facebook's newsfeed started using Bayesian personalization. Amazon's recommendation engine went full Bayes. The algorithm was eating the world, one probability distribution at a time. Your digital life became a series of Bayesian predictions, each click and scroll feeding into vast probability models that know you better than you know yourself. That targeted ad that seems to read your mind. That autocomplete that finishes your sentences. That music recommendation that hits just right. All powered by the same math that a Presbyterian minister worked out by candlelight in the age of pirates and powdered wigs. You're scrolling through your phone right now, probably in a position that would make your chiropractor weep. And every single app you touch is running some flavor of Bayesian inference. But let's talk about the dark side of this mathematical revolution. Remember when I said the algorithm learns from data? Well, guess whose data it's learning from? That's right, yours. Every search, every click, every pause as you consider whether to watch that video of cats being scared by cucumbers, it's all feeding the beast. You're not just using these services, you're training them. You're the lab rat and the scientist at the same time. Let me tell you about something called Bayesian spam filtering, because it's the perfect example of how this ancient math became your digital bodyguard. Before Bayes entered the chat, spam filters were like bouncers with a very specific list. If an email mentioned certain trigger words, boom, straight to spam jail. But spammers aren't stupid. They started writing things like V1 Agra, or using creative Unicode characters that looked like letters but weren't. The arms race was exhausting. Then someone had a brilliant idea. What if instead of fixed rules we use Bayesian probability? The filter learns what spam looks like based on examples, updating its beliefs with every email you mark as spam or not spam. It doesn't just look for bad words. It builds a probabilistic model of spamminess. The way sentences are structured, the ratio of images to text, the time it was sent, who else received it, Everything becomes a signal in the probability calculation. Now here's where it gets creepy. These Bayesian filters have become so good that they know your email patterns better than you do. They know that emails from your boss at 11 p.m. on Sunday are probably important, even if they contain words that would normally trigger spam filters. They know that newsletter you subscribed to 3 years ago and never read is basically spam to you, even though you technically asked for it. They're not just filtering spam, they're modeling your entire communication ecosystem, learning who matters to you and who doesn't, what you care about and what you ignore. It's like having a personal assistant who's been reading your mail for years and knows exactly what you want to see. But spam filtering was just the appetizer. The main course came when companies realized they could use Bayesian inference for behavior prediction. You know that moment when Amazon recommends something and you think, how did they know I needed that? That's not coincidence or mind reading. It's Bayesian inference working with collaborative filtering. The algorithm doesn't just look at what you bought, it looks at what people like you bought, what they bought next, what they looked at but didn't buy, how long they spent on each page. It builds a probability distribution of your future purchases based on the collective behavior of millions of users. You're not unique. You're a probability cluster in a vast mathematical space, and the algorithm knows which cluster you belong to better than you do. Let's get uncomfortable for a minute. Drop a comment if this has happened to you. You're talking to a friend about needing new running shoes, not searching, not typing, just talking, and suddenly Instagram is showing you ads for Nike. Your phone swears it's not listening, but the ads are too perfect, too timely. Here's what's really happening. The Bayesian models have gotten so good at predicting behavior from context that they don't need to listen to your conversations. They know you went to the gym more this week, tracked by your phone's location. They know your last pair of shoes were purchased 8 months ago, the typical replacement cycle. They know your friend just bought running shoes, and you tend to make similar purchases within 2 weeks of each other. The algorithm calculated the probability you're thinking about shoes and served the ad. No microphone necessary, just math. The revolution spread to healthcare faster than a viral TikTok dance. Doctors started using Bayesian diagnostic systems that could process symptoms, test results, medical history, even genetic data, updating disease probabilities in real time. Imagine you walk into a clinic with chest pain. Old school approach, the doctor runs through a mental checklist, maybe orders some tests, makes an educated guess. Bayesian approach, the AI instantly calculates probabilities for hundreds of conditions, updating with each new piece of information. Your age, gender, family history, the specific nature of the pain, recent activities, even the fact that you Googled chest pain symptoms at 3 a.m. last night. All of it feeds into the probability engine. The results were staggering. These systems started catching rare diseases that human doctors missed. They found patterns in test results that weren't obvious to the human eye. They predicted heart attacks days before they happened by detecting subtle patterns in seemingly normal EKGs. But here's the catch. When the AI says there's a 73% chance you have condition X, what does that really mean? The algorithm can't explain its reasoning the way a human doctor can. It can show you the probability calculations, the Bayesian updates, the prior distributions, but the intuition, the why behind the what, that's locked inside billions of parameters and probability distributions that no human can fully comprehend. Financial markets jumped on the Bayesian bandwagon like it was the last helicopter out of Saigon. High-frequency trading algorithms started using Bayesian inference to predict market movements, updating their models with every trade, every news article, every tweet from influential figures. These algorithms don't sleep, Don't panic, don't get greedy, they just calculate probabilities and execute trades faster than you can blink. The stock market became a battlefield of Bayesian algorithms fighting each other, each trying to predict what the others will do, creating feedback loops that occasionally flash crash the entire market because all the algorithms suddenly agreed on the same probability. You're living in a world where ancient math has become the invisible hand guiding everything from your Netflix queue to your investment portfolio. The same equation that Thomas Bayes scribbled down to understand divine providence is now determining whether you get approved for a mortgage, whether your resume gets past the first screening, whether you're flagged as a security risk at the airport. The algorithm doesn't care about your hopes, dreams, or circumstances. It only sees probabilities, distributions, statistical likelihoods derived from the digital breadcrumbs you leave behind. Here's where things get philosophically weird. The Bayesian revolution forced us to confront an uncomfortable truth about knowledge itself. There's no such thing as absolute certainty, only degrees of probability. Every belief, every piece of knowledge, every assumption you hold dear is just a probability distribution waiting to be updated by new evidence. The algorithm knows this. It embraces uncertainty as a feature, not a bug, but humans. We hate uncertainty. We want definitive answers, clear categories, black and white in a world that's infinite shades of grey. You know what's really messing with people's heads. The algorithm often knows things about us that we don't know about ourselves. There are documented cases of Target knowing a teenager was pregnant before she told her parents, based on Bayesian analysis of her purchase patterns. The company had to dial back their pregnancy prediction ads because they were creeping people out by being too accurate. Think about that. A mathematical equation from the 1700s combined with your shopping habits can detect biological changes in your body before you're consciously aware of them. If that doesn't make you want to throw your phone into the ocean, I don't know what will. The creepiest part isn't even the prediction accuracy, it's the feedback loops. When the algorithm predicts you'll like something and shows it to you, and then you do like it, was that a successful prediction, or did the algorithm create the preference by showing it to you? When YouTube recommends a video and you watch it, were you always going to watch that content, or did the recommendation create the desire? The Bayesian models are no longer just predicting the future, they're creating it, one probability-weighted recommendation at a time. Let me paint you a picture of your average day through the lens of Bayesian inference. You wake up and your phone has already predicted when you'll need traffic information for your commute. Your coffee maker started brewing based on the probability you'll want coffee, calculated from your sleep patterns tracked by your smartwatch. Your email is pre-sorted with important messages on top, spam filtered out, all through Bayesian classification. Your news feed shows articles selected by algorithms predicting what will keep you scrolling. Your music app queues up songs based on the probability you'll enjoy them, given the time of day, your recent listening history, and what millions of similar users enjoyed. Every interaction is a data point feeding back into the system, updating the probabilities, refining the predictions. You're living in a Bayesian bubble, a probabilistic echo chamber where algorithms show you what they think you want to see based on what you've wanted to see before. The ancient algorithm has created a mirror that shows not who you are, but who the math thinks you probably are. And the scariest part, the mirror is usually right. That's why these systems are so powerful and so dangerous. They work, they predict human behavior with uncomfortable accuracy using math older than America. Let's talk about the moment when everyone realized we'd opened Pandora's box and the instruction manual was written in 18th century mathematics. It's 2017, and suddenly every startup is slapping AI powered by Bayesian inference on their pitch deck, like it's a magical money printer. Your dog walking app? Now with AI, that meditation app? Bayesian mindfulness optimization. Even your smart toaster is apparently using probabilistic inference to predict optimal browning levels. The gold rush is on, and everyone wants a piece of the ancient algorithm. But here's what the tech bros weren't ready for. Bayesian inference doesn't just predict, it reveals. It strips away the comfortable lies we tell ourselves and shows patterns we'd rather not see. Insurance companies started using it and discovered that seemingly innocent variables like your email domain or your first name could predict accident rates. Banks found that the time of day you check your balance correlates with default probability. Dating apps realized that people who claim they don't care about height absolutely do, and the data proves it. The algorithm became a mirror that reflected not our aspirations but our actual behavior, and humanity did not like what it saw. You want to know something that'll make you paranoid? Right now, as you're watching this video, Bayesian algorithms are analyzing your watch pattern. Not just whether you watch, but how you watch. Did you skip the intro that updates a probability? Did you replay a section? Another update. Are you watching at 1.5x speed? That tells them something about your attention span and content preferences. Even your pause patterns. When you stop to check another app or grab a snack, feed into the model. The algorithm is learning you, building a probabilistic profile that knows your viewing habits better than your best friend. Meanwhile, in China, they're taking Bayesian inference to its logical extreme with social credit systems. Every action, every purchase, every social media post updates your probability distributions. Pay your bills on time. Probability of being a good citizen goes up. Jaywalk, probability goes down. Visit certain websites. Major update to your risk profile. It's Bayesian's theorem weaponized for social control, turning human behavior into probability scores that determine everything from your ability to buy train tickets to your children's school placement. The ancient algorithm has become the architecture of digital authoritarianism. But it's not all dystopian doom scrolling. Let me tell you about something beautiful that happened. Researchers started using Bayesian inference to decode locked-in syndrome patients' thoughts. These are people who are fully conscious but can't move or speak, trapped in their own bodies. The algorithm learns to interpret tiny changes in brain activity, building probability distributions of intended words and phrases. For the first time in years, some patients could communicate, could say, "I love you," could ask for the TV channel to be changed. The same math that's invading your privacy is also giving voices to the voiceless. The plot thickens when you realize that Bayesian inference isn't just changing what AI can do, it's changing how we think about thinking itself. Cognitive scientists started noticing that the human brain seems to work on Bayesian principles. Your brain is constantly generating predictions about what's going to happen next, then updating those predictions when reality doesn't match. That weird feeling when someone doesn't text back when they usually do. That's your brain's Bayesian prediction engine throwing an error. The surprise when a song doesn't go where you expected. Bayesian model violation. Your entire conscious experience might just be your brain's best guess about reality, constantly updated by sensory evidence. This revelation led to some wild experiments. Scientists gave people psychedelic drugs and watched their Bayesian priors dissolve. Turns out the feeling of oneness with the universe that people report on LSD might just be your brain's probability distributions getting scrambled. Depression might be stuck Bayesian priors that won't update despite contradictory evidence. Anxiety? Overactive prediction errors making everything seem like a threat. Mental health got reframed as a probability problem, and suddenly therapists were talking about updating priors and adjusting prediction errors like they were debugging code. But here's where it gets really weird. If our brains are Bayesian and AI is Bayesian, what exactly is the difference between human and artificial intelligence? Both are processing information, updating beliefs, making predictions based on probability. The main difference seems to be that we're running on meat hardware evolved over millions of years, while AI is running on silicon designed in the last few decades. But the underlying mathematical principles, surprisingly similar. It's like discovering that aliens use the same physics we do, comforting and terrifying at the same time. Companies started getting sneaky with this knowledge. They realized that if human brains are Bayesian prediction machines, you can hack them by manipulating prediction errors. That's why mobile games are so addictive. They create carefully calibrated probability distributions for rewards, keeping your brain's prediction engine constantly engaged but never quite satisfied. That's why social media notifications come in variable intervals. Fixed schedules are predictable and boring. Random schedules keep your Bayesian brain hooked, constantly updating probabilities, checking one more time just in case. You're basically walking around with a biological Bayesian computer in your skull that's being targeted by artificial Bayesian computers trying to predict and influence your behavior. It's an arms race between competing prediction engines, and guess which one doesn't need sleep, food, or bathroom breaks? The YouTube algorithm you're using right now has processed more data in the last second than your brain will in your entire lifetime. It knows patterns about human behavior that no human has ever consciously recognized. Comment below if that makes you want to go live in a cabin in the woods. The year is now 2018, and things are getting properly weird. Someone at OpenAI has the bright idea to use Bayesian inference not just for playing games or filtering spam, but for understanding and generating human language. They feed massive neural networks pretty much the entire internet, letting them build probability distributions over sequences of words. The result? GPT and its descendants, language models that can write, code, and create with terrifying fluency. The ancient algorithm has learned to speak, and it sounds disturbingly human. But language models revealed something unsettling about human communication. Turns out most of what we say and write is probabilistically predictable. Your emails, texts, even your supposedly creative writing, it all follows patterns that Bayesian inference can model and replicate. That heartfelt message you spent an hour crafting, an AI could generate something 90% similar in milliseconds. We like to think we're unique snowflakes, but to a Bayesian algorithm, we're more like predictable weather patterns. Sure, there's variation, but the underlying dynamics are mathematically modelable. The real mindbender came when researchers realized these language models weren't just mimicking human text, they were building internal representations of concepts, relationships, even what we might call understanding. When you ask GPT about Napoleon, it's not just retrieving facts, it's activating probability distributions across millions of parameters that encode relationships between Napoleon, France, war, exile, height jokes, and thousands of other concepts. It's building what cognitive scientists call a world model, except this world exists entirely in probability space. Here's something that'll keep you up at night. These Bayesian language models started showing capabilities nobody programmed. They could translate between languages they'd never explicitly been taught to translate. They could solve math problems by talking through them. They could write code in programming languages that didn't exist when they were trained. The ancient algorithm wasn't just learning what we taught it, it was discovering patterns and relationships we didn't know existed. It's like teaching someone arithmetic and having them spontaneously invent calculus. The implications hit different industries like dominoes. Journalism, AI can now write articles that pass for human written. Customer service. Chatbots powered by Bayesian language models handle complex queries without customers knowing they're not human. Education. AI tutors that adapt to each student's learning style, updating their teaching approach based on probabilistic models of understanding. AI that can analyze contracts and predict legal outcomes better than junior lawyers. The ancient algorithm isn't just revolutionizing technology, it's automating cognitive labor we thought only humans could do. And then someone had an even crazier idea. What if we combine Bayesian inference with image generation? What if we teach AI to dream in probabilities, enter diffusion models, where images are generated by reversing a process of adding noise, guided by Bayesian probability distributions? Now AI could create art, design products, generate photorealistic faces of people who never existed. The ancient algorithm had learned to see, speak, and now imagine. Thomas Bayes probably never imagined his theorem would one day create pictures of astronauts riding horses on Mars, but here we are. So here you are, living in 2024, surrounded by the invisible tendrils of an algorithm conceived before America was a country. Every swipe, click, and keystroke feeds into vast Bayesian networks that model not just your behavior, but your desires, fears, and dreams. You're living in the future that science fiction writers warned us about, except it's powered by math so old that it predates the steam engine. Let me tell you what's happening right now, at this very moment. As you watch this video, your smart TV or phone is calculating the probability you'll watch another video after this one. It's considering factors you're not even conscious of, like the micro movements of your eyes tracked by the front-facing camera, the way you're holding your device, whether you've shifted position in the last 5 minutes. All these signals feed into Bayesian models that predict engagement better than you can predict your own behavior. The algorithm knows you're getting sleepy before you do, knows you're losing interest before you consciously decide to click away, knows what thumbnail will make you click, even when you swear you're done with screens for the night. But here's the thing nobody talks about. We've created a world where opting out isn't really possible anymore. Try to get a job without digital profiles that have been analyzed by Bayesian algorithms. Try to get insurance without your data being run through probability models. Try to even exist in modern society without leaving digital footprints that update someone's Bayesian priors about who you are and what you're worth. The ancient algorithm has become the invisible infrastructure of modern life, as essential and unnoticed as electricity. The really wild part is what's coming next. Researchers are working on Bayesian models that can predict not just what you'll do, but what you'll think. Brain-computer interfaces that use Bayesian inference to decode neural signals in real time. Imagine thinking about moving your hand and a robotic arm moving instead, guided by probability distributions of your intended motion. Imagine composing music by thinking about how you want it to sound, with Bayesian algorithms translating your neural patterns into notes. The boundary between thought and action, between intention and reality, is dissolving into probability distributions, and it's not stopping there. Quantum computers are about to supercharge Bayesian inference beyond anything we can currently imagine. While classical computers process probabilities sequentially, quantum computers can explore multiple probability paths simultaneously. It's like the difference between searching a maze one path at a time versus exploring all paths at once. When quantum Bayesian inference becomes practical, and it will, the prediction capabilities will be so advanced they'll seem like magic, or time travel, or both. Let's get real about what this means for you. Sitting there, probably procrastinating something important. The Bayesian revolution isn't some abstract technological shift. It's reshaping what it means to be human in the 21st century. Your kids, if you have them or plan to, will grow up in a world where AI tutors, using Bayesian inference, adapt to their exact learning style, predicting what concepts they'll struggle with before they do. They'll never know the frustration of a one-size-fits-all education, but they'll also never know the privacy of thoughts unobserved, of behaviors untracked, of mistakes that don't update a permanent probability profile. The job market is transforming into a Bayesian battlefield. Your resume isn't just a list of experiences anymore. It's a collection of data points that update an employer's probability distribution about your future performance. That gap year you took, the algorithm has probability distributions for what that means. That online course you completed, another Bayesian update. Your social media posts, your GitHub contributions, even the speed at which you fill out applications, it all feeds into models that decide whether you get an interview before a human ever sees your name. Relationships are getting the Bayesian treatment too. Dating apps have moved beyond simple matching to complex probability models that predict relationship success. They analyze text patterns to assess compatibility, response times to gauge interest, and profile views to model attraction. Some apps are experimenting with Bayesian models that learn your true preferences versus your stated preferences. You say you want someone who loves hiking, but you consistently match with gamers. The algorithm knows your real type better than you do. It's updating its beliefs about what you want with every swipe, building a probability distribution of your ideal partner that might surprise even you. The healthcare revolution is just beginning. Imagine wearing a device that continuously monitors your vitals, updating Bayesian models of your health in real time. It doesn't wait for symptoms to appear. It detects probability shifts that indicate something's wrong days or weeks before you feel sick. Your doctor, or more likely an AI medical assistant, receives alerts when your probability of developing certain conditions crosses threshold values. Medicine shifts from reactive to predictive, from treating disease to preventing it, based on probability distributions updated with every heartbeat. But here's the dark side nobody wants to discuss. These systems are only as good as their data, and data reflects all our human biases, prejudices, and systemic inequalities. The Bayesian models learn from historical data that include centuries of discrimination. They pick up patterns that correlate with race, gender, socioeconomic status, even though these variables might not be explicitly included. The ancient algorithm doesn't care about fairness or justice. It only cares about probability, and if the data says certain zip codes correlate with certain outcomes, that's what it learns. So where does this leave us? Are we heading toward a Bayesian utopia where perfect predictions eliminate uncertainty and suffering, or a probabilistic dystopia where human agency dissolves into statistical determinism? The answer, appropriately enough, is probabilistic. Multiple futures exist in superposition, their probabilities shifting with every decision we make today. Here's what I think, and drop a comment if you agree or if you think I'm completely wrong. The ancient algorithm that revolutionized AI in 2016 isn't good or evil. It's a tool, like fire or electricity, or the internet. Fire can warm your home or burn it down. Electricity can power hospitals or electric chairs. The internet can spread knowledge or misinformation. Bayesian inference can predict diseases or perpetuate discrimination. The algorithm itself is morally neutral. It's what we do with it that matters. The real challenge isn't technical, it's philosophical. We need to decide what role we want probability to play in human life. Should every decision be optimized based on Bayesian predictions? Should we sacrifice privacy for better predictions? Should we allow algorithms to make decisions about human lives based on probability alone? These aren't questions that Thomas Bayes could have imagined when he was working out his theorem by candlelight. They're questions we need to answer, and soon, because the algorithm isn't waiting for our philosophical debates to conclude. You have more power than you might think. Every time you choose to share or withhold data, you're affecting the probability distributions. Every time you act unpredictably, you're adding noise to the models. Every time you question an algorithmic decision, you're asserting human agency over mathematical determinism. The ancient algorithm might be powerful, but it's not omnipotent. It can only predict based on patterns. And humans, beautiful chaotic humans, have the capacity to break patterns, to choose the improbable, to surprise even the most sophisticated Bayesian model. As we wrap up this journey from 18th century mathematics to 21st century AI, remember this. You're not just a probability distribution. You're not just a collection of data points updating some cosmic Bayesian model. You're a conscious being with the power to choose, to change, to defy prediction. The ancient algorithm might know what you're likely to do, but it can't force you to do it. At least not yet. So here's my challenge to you. Go do something unpredictable today. Break a pattern, confuse an algorithm, watch a video you'd never normally watch, buy something weird, take a different route home, text someone you haven't talked to in years. Add some chaos to the probability distributions. Remind the machines that humans aren't just predictable patterns but conscious agents capable of beautiful, irrational, unpredictable choices. If you made it this far, you're probably the kind of person who thinks deeply about these things. Leave a comment telling me about a time when you defied an algorithm's prediction, when you chose the improbable path, when you proved that human consciousness is more than just Bayesian inference running on biological hardware. And if this video made you think differently about the invisible mathematics shaping your daily life, hit that like button and subscribe. Not because an algorithm predicted you would, but because you choose to. Peace out, and remember, in a world of probabilities, the most radical act might just be embracing uncertainty.